This Sinometer VC2000 frequency counter. I got this on Amazon. I have it hooked up to my Siglent frequency generator over there on the side. I don't remember if it came with a BNC cable or not. This is my BNC cable and my 50 ohm terminator that I've used with it. It did come with a power cord and it did come with a manual. The manual says Untitled Frequency Counter Operations Manual. It's very short, just a handful of pages. Right now I have it. I have the Siglent configured to send a 1 kilohertz waveform to the frequency counter, which is displaying there as 1.0, and then the last digit is kind of oscillating a little bit between 0 and 1. This counter has a total of 2 jacks. The bottom jack is for 10 hertz to 50 megahertz. The top jack is for 50 megahertz to 2.4 gigahertz. We can set the gate time on it. The gate time is how often it updates the display. Right now I have it set for 0.1 second, which is very quick. If I set it to 1 second, you'll see it updates slower, but we gain an extra digit of precision. We can go to 5 or all the way up to 10 seconds. At 10 seconds you can see we've gained a lot more digits of precision, but it updates much slower. Another couple, there we go. There's a good read on our 1 kilohertz signal. So let me set the gate time back down to 0.01. So every time after you've changed a parameter, you got to push the run button. So I can ramp this up. So there's 10 kilohertz, 100 kilohertz, all the way up to a megahertz. Now there's a total of 5 different ranges that this thing supports. 3 of the ranges are frequency ranges. One's a period, one's a crystal oscillator measurement. You kind of have to memorize how the ranges work. So it is in the manual. There's a, let me hold that where it can be seen. There's a chart there that specifies them out. So ranges 1, 2, and 3 are the frequencies. Range 3 happens to be the B jack in kilohertz. If we go to range 2, that is the B jack in megahertz. So we can keep on going up with this. There I've sent my Siglent output 10 megahertz. Everything is working kind of as expected. Can bring my Siglent up to its maximum of 25 megahertz, and that's as high as I can go with this frequency generator. And then we will have to switch to a different frequency generator to hit the higher range on it. So here I have it hooked up to my my home-built RF generator. It goes up to about 107 megahertz, so we can use it to stress this frequency counter a little bit more than I was getting out of my arbitrary waveform generator. So I've got this set right now for bringing it to close to as 50 as I can tune it with a potentiometer. Got it set to 50.037038 or so. So yeah, it's reading 50. So 50 was the top end of this B jack down here in the range 3. So if we want to go higher, go up to here, we will switch to range 1. And now we should be able to go all the way up to as high as my RF generator goes, which is about 128 megahertz. So yeah, there it's working. I don't have anything that goes any higher, so I can't test this any further. It says it counts all the way up to 2.4 gigahertz if you had something that would produce signals in that range. Okay, so the other thing this does is it has a count mode. The count mode is range 4. I've connected my arbitrary generator again and set it to output at 10 hertz. And we will see what the count mode does. It just simply displays a count of the cycles it's receiving. So this is updating about 10 cycles per second, which is exactly what I set the frequency generator for. So the final thing it has is this crystal oscillator measuring mode. So to do that, you put it in range 5, set the oscillator in kilohertz. You push in the crystal oscillator button, you hit run. Now this is a 32.768 kilohertz crystal. And it says 147 kilohertz. That does. Yeah, this should be 32.768. Maybe it's not the right kind of crystal. I do have some other crystals. I have a 5 megahertz crystal. We put this one in. Yeah, that's working. So 5 megahertz. Yeah, so it's working with a 5 megahertz crystal. Here's a 12 megahertz crystal. You can rightly know what these things are for. I bought them for some reason. There's a 12 megahertz. Let's see if it can measure that. Yeah, 12 megahertz. Don't really like how it just kind of seems kind of sloppy in there. But basically working. Let's look at the rest of the thing. Overall construction. It's a plastic case. There's an on-off switch on the back. It's got some kind of fuse holder, your standard power receptacle. You've got 110 volt versus 220 volt you can select. Overall construction seems to do what it's supposed to do. Okay, now let's take the thing apart and see what's inside of it. I don't see any of those warranty void stickers. I'm going to try just taking the screws loose from the bottom side and seeing if it'll come apart. One of these is a machine screw, the other's just a screw to hold the foot straight on there. So I'll bet the machine screw is holding the case halves together. Same thing here, machine screw and metal screw. Let's see if we can get this part to come out with the bottom. There we go. So it's got some kind of a ground shield on the top there and a ground shield on the bottom. Inside, let me see if I can tell what chips the thing is using. I will zoom in just for anyone who wants to see. And a backside view of the front panel. Wish we had some more light. There, we can get a close zoom in that way. I took a moment to look at the chips, and here we have an Atmel 89C2051-24PU. Over here we have a 74LS373. Here is a 74HC393N. 74F74, 74HC153, an Atmel 93C46, and an LM393. This here is a 7805 regulator on the heatsink. I don't really know what's inside of these cans because they're soldered down and I don't really want to take them apart. The transformer is 9 volt. I'm not really going to bother with looking at the front panel. So this particular small can here was not soldered down on one side, so I was able to kind of pry it up. And what we can see in there is some kind of a crystal, and glued to it is a 3-terminal semiconductor of some place. I don't know, I would guess a temperature sensor, but you know, it's got the white gunk all over it, you can't really tell. Now, I'd sure like to get in there and look at it, but I don't really want to tear it apart, so it will remain a mystery. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.